Okay. Today we're going to talk about properties and changes of matter. So we'll review this tutorial, and like I do with all the tutorials that I review, I let you watch the videos and answer the questions on your own. I'm basically just going to give you like a better understanding of some of the definitions and other stuff going on in there. And these have kind of gone along with other little mini lessons that I have done as well. That should help you. Okay, so we'll look at properties of matter in this tutorial. Now, we'll do this one first. So we have a Venn diagram here, and what we have, like a Venn diagram, just a quick refresher. Um, the stuff on the outside of the circle, so like on the opposite circles, means that they're not alike. The stuff in the middle means that they have something in common with each other. Okay, so we have, let's see, wood is flammable, and things that are both flammable, they both have something in common. Let's see, flammable and white. So things they have in common, there's paper and candles. They are also both flammable. And let's see, white, salt, and snow, we know they are not flammable. Therefore, they are in that column. Wood, we know is definitely flammable. The properties of matter. Let's get into this. All right, so let's look up that definition. It's a special characteristic or quality that something possesses. So that's what a property is. So a special characteristic, we could say, I have brown hair, my dog has black hair. Special characteristic about somebody or something. So for an example, let's look at this chemical reaction we have here. It says baking soda is chemically known as sodium bicarbonate. So that is like the official chemical name for baking soda. Chances are you are only going to see it written as baking soda though. It's white powder at room temperature. So, but when it's added to water, it dissolves in the water. There's no reaction that takes place when it dissolves in water. It's just there, dissolved in water. That's it. When it dissolves in vinegar, it creates like this fizzing, bubbly reaction. In fact, I'll probably do that as some sort of experiment as well, just to show you what that looks like. But it's just like this little bubbly reaction that takes place. It's a chemical reaction. Baking soda and vinegar do react together. Okay, physical properties. So that is a characteristic of matter that can be observed without changing the composition of it, meaning it's not going to change. Physical properties. So I reviewed this before, but it's something along the lines of its mass, volume, melting point, boiling point, color, texture, smell, size, something along those lines would be like a physical property. Density. Okay, so in a quick mini lesson I've shown you how to calculate the density with the formula and a math problem, but we'll just get into it a little bit deeper right here. Density, the definition, the mass per unit volume of a substance. Okay. So density describes the relationship between the mass of a substance and its volume. That's why it's mass divided by volume. For an example. So there's an example here. Feathers have a low density, lead has a high density. So of feathers, let's see, 1 pound of feathers versus 1 pound of lead, you would need a lot more feathers than you would need for lead. So lead, you'd probably need a small piece of lead, and it would be about a pound. Feathers, you would need a whole lot of feathers to create 1 pound because they're lighter, lower density, lower mass. All right, let's go to the next part. Okay, calculating density again. I've done this before where in a mini lesson again. Density is mass divided by volume. So how you do this. Okay, so the blocks of wood, the mass is 14 grams, volume is 28 centimeters cubed. Cubed because again, volume is length times width times height, okay? Now, Density, again, mass divided by volume. And we're going to say the mass is 14, so 14 divided by 28, which is the volume. And that equals out to be 0.50 grams slash centimeters cubed. Now, this is how you would write it afterwards, grams slash centimeters cubed, because it's both grams divided by centimeters cubed. Okay, let's go on to the next part. Question, we'll have you fill this out on your own. And remember, mass divided by volume. Okay, we'll just kind of skip over this part. So let's look up chemical properties. So a chemical property, a characteristic of matter that it involves its ability to change into one or more new substances. Okay, so for an example, and this is probably my favorite example, there was also a mini lesson on this, toasting bread. So did you know that toasting bread is a chemical change, chemical reaction takes place because the sugars interact with the amino acids. So it's changing, something is changing on the bread, it's getting toasted, can't change it back or reverse it back to its original piece of bread. So let's see, what else about chemical properties? Chemical properties of a substance cannot be identified just by looking at it or touching it. So that means that you'd have to observe something else. You'd have to observe the change in structure and something else that is taking place. But for an example, whether a substance burns in a flame and whether it reacts with an acid or oxygen are chemical properties. So chemical property would be like wood burning, creating a fire, fireworks, something along those lines. Okay. Now let's go to our next question. Let's this is a little just review, so I will read this one to you. So a physical property of tin. So here, this is a physical property. Physical property versus chemical property. The melting point of tin is 231.9 degrees Celsius. That is a physical property because the melting point likely will not change on tin. The melting point or boiling point of anything or freezing point likely is not going to change. So that we would call that a physical property. So again, the melting point of tin is 231.9 degrees Celsius, physical property. The density of solid silver is 10.49 grams centimeters cubed. So that would be a physical property of silver. So the density of solid silver would be this, likely probably would not change. That's physical property. Water, pure water, is odorless. Water does not have a smell to it. That is a physical property that we can know, we can observe. Chemical properties, a little different. Let's get into that real quick. Acetic acid can react with another substance and change its color. So changing the substance into something else, reacting, you'd have to have a reaction take place for chemical property. Sodium can react with water to form sodium hydroxide and hydrogen. So it's reacting, again, another reaction is taking place to form two different things. So it's going to form sodium hydroxide and hydrogen. Okay. Iron. Iron does not burn when it is exposed to a flame. Interesting, but true. All right, now we have, let's see what else. Substances by their properties. Okay. So extensive properties of a substance change if the amount of the substance changes. Okay, so this would deal with mass, volume, length are examples. So they change if the amount of the substance changes. So let's say you had 2 ounces of water, 4 ounces of water. If something changes, you lose mass, so you lost some weight. You're losing mass. So that's an extensive property because something is changing. Intensive property. They don't depend on any on the amount of the substance. Intensive Intensive properties include odor and melting points and boiling points. So again, that likely wouldn't change with the substance either, but any amount of water. So like it says here, any amount of water is always going to have the same melting point, same boiling point. Any amount of tin, like we saw on the other slide, will have the same melting point. Density is an intensive property because if the amount of the substance is increased, its mass and volume both increase proportionately. So the mass and volume, if the amount of the substance increases, the mass and the volume increase at the same rate. So the density will always remain the same. It doesn't change. Temperature is also an intensive property. Okay, so then here we have examples of intensive and extensive properties. And let's just, I know this is, I said that I would not do the questions. I will review this one though. I feel like it is a little bit important to just review. Intensive properties, the boiling point of methane is negative 161.5 degrees Celsius. So that would be intensive. It's not going to change. Chlorine gas is green. The color likely would not change on chlorine gas. And the freezing point of ethanol is a 114.1 degrees Celsius. Again, that's not going to change. Extensive properties. The sample of steel is 2 meters in length. So a sample of steel is 2 meters in length. That can change because say you have a sample of steel that is 1 meter. Changes. The water in a beaker has a volume of 50 milliliters. Okay, again, you could fill the beaker up to 40 milliliters, 20 milliliters, 0, something like that. So that would change. A sample of gold has a mass of 5 grams. Well, what if you get a sample that has 4 grams? So see, it can change. All right, well, this just talks about extensive properties, density, stuff like that. Let's go to the next part. And then if you click the link, there is another article about diamonds. It talks about what happens to make diamonds at carbon crush. Diamonds are made under pressure. Just fun fact. And we'll let you read that on your own as well. Changes in matter. All right. Again, physical change, a process by which the form of matter is changed, but one substance is not transformed into another. Chemical change, the process by which one or more substances are changed into a new substance or substances with a different identity. So it changes its identity entirely. It becomes something new. And you can't revert it back to what it used to be. Okay, this just goes into a little bit more depth about physical changes. So let's see. We'll just have you read this part over. But here's a good point right here. This is that there is no change in the chemical properties of the substance during a physical change. Changes in state, such as from liquid to gas, are common examples of physical change. Some examples of physical change are changes in texture and shape. Because it's not changing the substance, it's still the same thing. And that is the important part right there. Here, though, let's say, okay, I'll have you read this over, but let me pull out the important part. Because a substance undergoing a chemical change turns into a different substance, both its physical properties and chemical properties change. So that's what happens. It's chemical change is also called a chemical reaction. Basically, something different is occurring to change the substance. So examples of rusting of iron, burning of natural gas, baking soda and vinegar, carbon dioxide, it produces carbon dioxide bubbles. So something is changing. Fire. Oh, did you know that a banana becoming ripe is also a chemical change? It changes its properties and everything completely. Fun fact. So physical change, we will do this question too, just so you get a better idea. Physical change, aluminum melts and is poured into mold. So that's just melting it. It's still aluminum, so it's just melting. Liquid substance boils and decreases its volume, boiling, boiling water. A block of wood is cut into three pieces. And if you saw, I did a similar mini lesson with physical changes where I just cut a piece of paper to represent physical change, showing that I cut the paper into four pieces and you can put it back together how it used to be. Chemical change, when two clear liquids are mixed, a red solution is formed. So let's see. Could be like acid versus base, or you're mixing an acid with the water. That's why the red is formed, something like that. You're changing something about it. When two clear, colorless liquids are mixed, a green liquid is produced. Something else. A powder ignites and burns when it is exposed to heat. All right. Summary, and there you have it. These are just more examples of physical properties. Again, mass, volume, melting, boiling, color, texture, smell. Okay, chemical properties. Let's see, describes its ability to change into something different, the ability to rust, and the ability to burn. And real quick, we'll go back to that. That's why I say toast, because you're burning the bread. You're changing the bread, you're burning it. So that's easier. Intensive and extensive properties shows you how they change. Physical changes. Whoops, let me go there. Okay. Chemical changes. And that's the last of the summary. And there you have it. That is the tutorial on properties of changing matter.